let's do some guided practice for derivatives and rate of change. Find the derivative at the specified point. Now, they don't actually give you the point. They say find f prime of negative 1. The point would actually be, just to make the question make sense, would actually be negative 1 comma f of negative 1, right? That's the actual point, which is negative 1, and then if you plug in negative 1, you get 2 plus, I think it's 7. Yeah, I think you get that, okay. So let's maybe touch that up a little bit, right? Just touch it up a little bit. Touch it up a little bit. Super quickly. All right, and then let's move this guy over here. Much better. So, okay. I'll just say at that. Okay, anyway. We know that we're finding f prime of negative 1, which is the limit as h approaches 0 of f of negative 1 plus h minus f of negative 1 all over h. Now remember, we know what f is, so let's just plug in negative 1 plus h. Now it's going to be a little bit nasty, right? We're going to have to do that. We're going to have to FOIL that. And then I guess, assuming we did that properly, we know that we get 7, right? F of negative 1 is 7. Just to highlight what we're doing here, this turns into this. This turns into this. And of course, we've got our h at the bottom. Now again, no easy way to do it. Or I should say no super nice way to do it, right? 2 on the outside, we're going to get 1 minus 2h plus h squared on the inside. That's going to be plus 4 minus 4h. Just be a little careful with the negative signs. All right, and then this just requires even more simplification. Sometimes my h's are going to look like l's, right? They're h's, right? 2 minus 4h plus 2h squared. All right, I distributed this 2. Plus 4 minus 4h plus 1 minus 7 all over h. Now, at this point, remember what we did last time? We know that we've got a 0 over 0, right? We know that that's a problem. We could have noticed that right up here, actually, right? What we need to do is cancel out that h on the bottom. Every single time, the goal is to get rid of that. All right, well, first of all, notice that we need to get rid of the constant terms in order to do that. And they always work out, right? It's 7 minus 7. That should always work out that way. So what we're left with is the limit as h approaches 0 of, and now I'm going to clean up the top a little bit. It looks like we've got 2h squared minus 8h all over h. Again, it's still 0 over 0, but that's a lot nicer to work with. Right, because now I think you can see we can factor out an h, right, just, right, just factor out that h, and we get that, and that gives us, that gives us 1, and that gives us negative 8, right, okay, negative 8. All right, next one. F of x equals that. Oof, radical, nasty. All right, well, again, what they really mean to say is we're looking at the point 5 comma f of 5, which is square root of 9, which is 3. Okay. It's really at, right? Now, note that the 3 doesn't really matter, although calculating it now saves us a little bit of work when we find the derivative, right? But anyway, f prime of 5 equals limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. And this is going to be the square root, Let me move that down a little bit there. Of 2 times 5 plus h minus 1. Everyone see what we're doing there? We substitute 5 plus h in for x. Minus the square root of, well, we know that it's going to be 3. But if you're not sure how we got that, it was 2 times 5, right, f of 5, minus 1 all over h. Let's simplify that a little bit. We're going to get limit as h approaches 0 of, looks like 10 plus h minus 1. Or sorry, 10 plus 2h minus 1. Let's simplify that a little bit. Simplify that a little bit to 9 plus 2h. And then here we're going to get minus 3, right? And then divided by h. Now remember, at this point, we always have 0 over 0. You don't need to write it, but just to point out, we always have a 0 over 0. So what do we do in this situation? Where we've got a 0 over 0 indeterminate form, and we've got a radical. That's right. We multiply it by the conjugate over the conjugate. All right, so this is going to be the limit as h approaches 0 of, well, once you multiply by the conjugate, the radical is going to go away. You're going to have minus 3 times 3. And the bottom is going to be a mess, as it always is, but that's okay. Remember, the thing we need to get rid of is this h. That's always the goal. Well, as always, these guys cancel out. And oh, what do you know? Those h's are going to cancel out as well. Well, let me write that in red, maybe. Right, so this is going to give us the limit as h approaches 0 of 2 over, well, this lovely radical right here. And then as h approaches 0, we get 2 over root 9 plus 3. And that's just equal to 2 over 6 or 1 over 3. Okay? So, turns out that that's our answer. The derivative at the point 5 comma 3 is 1/3. Last but not least, find f prime of 3. Now, again, they said at the point. This should really say at the point 3 comma 1. Okay? F prime of 3 equals limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. Right? And then let's think about this, right? What's that going to give us when we plug 3 plus h in? Well, nothing lovely. We're going to get 1 over 3 plus h minus 2. It's actually not that bad. Over 1 minus over 3 minus 2. And then this is all over h. You see that? Yeah, nothing super nice. In fact, let me even just move this limit term down a little bit just so you see what's happening, right? All right, well, we can make this is going to be nasty if we have continued fractions. So one trick that I'm going to use right here, instead of writing all of it over h, I'm going to pull the 1 over h out, okay? And then let's simplify the fractions. We have 1 over 1 plus h minus 1 over 1. Right? Or just 1, you could say. Okay? Well, anyway, what you need to do, this is one of these, it's like, it's a 0 over 0 limit. But here it's just sort of a, infinity times 0. Which turns out is another indeterminate form, right? But if you rewrote it as a fraction, then it would be 0 over 0, right? So what we need to do is, well, what do we do when we have fractions and we need to simplify the fraction, right? Common denominator. So that's going to be 1. Whoops, let me get that h looking good. Okay, so it's going to be 1 over h. Don't forget about that. It's going to be 1 is the same as, let me just sort of squeeze this in here, times 1 plus h over 1 plus h, okay? So what we're going to do is this is going to be 1 minus parentheses 1 plus h, be careful with those parentheses, over 1 plus h, okay? And then when we take the limit, right, or we don't take the limit quite yet, but when we do it out, this is the same as 1 minus 1 minus h. Be very careful. That's what I meant by be careful with those parentheses, right? The minus distributes, right? Anyway, ones cancel, right? And now we have negative h over, and I'm just going to lump the 1 over h back in here. And oh, what do you know? That's kind of nice. And now we can finally take the limit, and we get negative 1 over 1, which is just negative 1.